chord. Okay, so I'm going to recap this. I just taught it in class. I'm going to go over it again real quickly for anybody who wants to watch it again. But anytime all you know is side-side angle, that's all I have is a side-side angle. One of three things can happen. Either the triangle will not exist. That's why we draw it to scale. You'd never know unless you drew it to scale. One triangle exists. Again, if you draw it to scale, it's easy to see. And then the third possibility is there's possibly two triangles that exist. Okay, I have a big triangle and I have the little yellow. So here's the three possibilities. First of all, in triangle 1, if I drew it to scale, I made a 40-degree angle. Use my protractor. I get 40 degrees. Okay, 10, 20, 40. I drew my angle. I used my ruler to measure this side. This side is 6. So I'm going to use my ruler to measure that. And of course I don't have my ruler. Here it is. Here's my ruler, and I measured that to be 6, and I drew that all the way to there. And then if this is angle A, little a is just, this has got to be side A because angle A is side A. But side A is 3 centimeters, so when I try and draw it, it doesn't work. It doesn't touch. That's not a triangle. So the dreaded side-side angle, or if you say it backwards, it's the bad triangle. One possibility is it doesn't exist. If you tried to set up the law of sines on that, you could have had the sine of theta over 6 equals sine of 40 over 3. And if you try to actually do it on your calculator, you're going to find that it will not work out. Whoops, I'm clear. Hold on, delete. 6 out of 40 divided by 3. And if I do the sine inverse, because I'm looking for the angle, that answer won't work. Okay? So if you happen to do this problem without drawing to scale, you come across that, something's weird. Did I draw it wrong? Did I set it wrong? No. You didn't do anything wrong at all. It just doesn't exist. Okay, then example 2, we went through, we drew it. Again, I made a 40-degree angle here. Here's my 40 degrees. I use my ruler to draw this 6. There it is, 6. Side A is 7, so I had to make it fit. I had to make sure the 7 fits, so I moved my ruler over until my 7 fit on the line. There's my 7. I have to draw it right there because 7 touches right there. None of this makes it 7, so I drew that in. And then this triangle does exist, so I set up the law of sines. I've got my opposites. I have a 6. I can find its opposite, so I found angle B first. Sine of B over 6 equals sine of 40 over 7. Cross multiplied. Use my calculator. I got a decimal. I need the angle, so I went the sine inverse of that, and I ended up getting a 33.4. I got angle C because I knew that 3 angles in a triangle add up to 180, so I went 180 minus the sum of these two, and I get 106. And then finally, if I want this side C here, again, opposites. I set up side C over the sine of its angle equals 7 over the sine of its angle, cross multiplied up here, and I ended up with about 10.4, okay? The third possibility in the dreaded side-side angle is where 2 exists, okay? So real quickly, if you were to draw the first triangle, I want to show this to you. Side A and 40 degrees, angle A, 40 degrees. B is 6. I like to put B here. If you put B on the bottom, it's just going to be upside down. It can be upside down. It's just easier to see it this way. Side B is 6. And then you have the possibility of side A. Side A is 4. So what happens is it could be drawn right there. which makes a triangle. But it could also, if I want side 4, 4 actually fits also on the inside. 4 could also be right there. So there's two possible triangles that could work. One is the one we all first suspected, this big one in gray, which I solved the big one in gray here using the law of sines. Or you could also have a second triangle right in here, and both triangles are correct. So I solve for the big triangle first, ignoring the little one. Again, I use the law of sines. Sine of b over 6 equals sine of 40 over 4. I got angle B. Then I got angle C from 180 degrees. And angle C was about 65.4. I got side C, which is all of this. And I got side C again by the law of sines. Now, when I went for the little triangle, I do the exact same thing, but there's a thing that we have to be very careful on, and that is angle B is no longer here. Angle B is there. And angle B is this obtuse angle. The way we get angle B, here's the trick. If you look at this triangle here, which is not part of the problem, it is a nice sausage triangle, 4 and 4. If two sides are angled, so are the base angles. So that's equal to that. Therefore, we can get angle B from subtracting from 180, because these two angles make 180 because it's a straight line. I got angle B then to be 105.4. Just subtracted these. Then I get this angle C here from 180 degrees, right? And then I can find side C by, again, the law of sines. Side C over the sine of its angle equals 4 of the sine of 40, and I got about 3.53. So there's the homework for today. Most of you are in class, so this, if you watch it, this will be a nice little review. Or you already got it, right guys? You already got it.